Hello everyone. In today's lesson, we're going to be going over the product and the quotient rule for solving derivatives. So let's start with a couple rules. The first is our product rule. So our product rule says that if we have the derivative d dx of two functions multiplied by each other, f of x and g of x, let's say, then this is going to be equal to f of x times the derivative with respect to x d dx on the function g of x plus the function g of x times the derivative d dx on the function f of x. Or you could think of this as g f prime plus f g prime. Now you may have noticed that I flipped these around, right? So if you actually looked at the way I wrote it originally, it was f g prime plus g f prime. I actually switched this because these are associative and they're commutative, so it really doesn't matter what order we put them in. But the reason I did this is because as we go into our quotient rule, which states that if we are taking the derivative d dx on two functions f of x divided by g of x, in this case, the order is going to matter. And this is going to be equal to g of x d dx of the function f of x minus f of x d dx g of x, and then this entire thing is divided by g of x squared. So you can think of this one as g f prime minus f g prime divided by g squared. And this is the reason why I wrote our product rule this way, because that way, if you remember this one, all you have to remember for the quotient rule is that instead of plus, it's minus and divide by g squared. So what this means is for the product rule, we're going to take our g of x and we're going to leave it alone. And then we're going to multiply that by the derivative of f of x. And then we're going to add that to, leave our f function alone, and multiply that by the derivative of g of x. For our quotient rule, we're going to take our g function, leave it alone, and multiply that by the derivative of our f function, minus leave our f function alone, and multiply that by the derivative of our g of x, and then divide the entire thing by g of x squared. Now we also have a couple more things we want to cover in this section, which is some more trig functions. So we already talked about two of them, which are if we have d dx of sine of x, this is just going to be equal to cosine of x. And if we have the derivative d dx of cosine of x, this is going to be equal to minus sine of x. Now we're going to add to this and say that if we have our function d dx on tangent of x, this is going to be equal to secant square of x. And if we have the derivative d dx on cosecant of x, this is going to be equal to minus cosecant of x times the cotangent of x. If we have the derivative d dx for the function secant of x, this is going to be equal to secant of x tangent of x. And then finally, if we have the derivative d dx of cotangent of x, this is going to be equal to minus cosecant square of x. Now, you can actually solve these using our definition of a derivative, right? We've talked about using this. It works for everything, but these rules will also be true when you have these. And a lot of times the way you want to solve this is you want to use things like the property that if I have the tangent of x, this is going to be equal to having sine of x divided by cosine of x. And then from there, a lot of times this is going to lead to cancellation or changing this into different things like cosecant. Or for example, if I have tangent, sine over cosine, cotangent would be cosine over sine. So in this case, once you get it in terms of sines and cosines, when you do a bunch of cancellation and moving things around, you can actually figure out these doing it that way. So now we're going to do some examples. Now, if you notice in the side here, I put the product rule and the quotient rule so we can reference them while we're doing these problems. So the first one says that we want to differentiate y equals x squared sine of x. So if you look at this, this is going to be our product rule, right? This x squared is going to be our f, and this sine of x is going to be our g. So looking at our product rule, we have g f prime plus f g prime. So the first one, we're going to leave our g alone. That's our sine of x. So the derivative of this, y prime, is going to be sine of x times. Now we want to take the derivative of our f of x, which is x squared. So we use our power rule. X squared becomes 2x. The square was 2 minus 1 with a power, so that gives us x to the 1. So this becomes 2x plus. Now for our second term, we have f g primes. We want to leave our f alone, so this is going to be x squared. And then we want to take the derivative of our g of x, which is going to be sine of x. We take the derivative of that, we get cosine of x. And then, of course, just rewriting this, just to have the x's in the front, this is going to be 2x sine of x plus x squared cosine of x. For my next example, I want to take the function f of t, which is equal to the square root of t times a plus bt. And I want to differentiate this. Now, a couple things before we do this. First of all, is that I'm actually going to change this square root of t into t to the 1/2. This will make it easier when we're actually taking the derivatives. Second thing I want to mention is that this a and b are just constants. So this is going to be t to the 1/2 a plus bt. So this t to the 1/2, this is going to be our f. This a plus bt, that's going to be our g. And because we're multiplying them by each other, this is going to again be our product rule. So when we take the derivative of this, f prime of t, this is going to be equal to, well, first we leave g alone, so this is going to be a plus bt. And then we multiply by our f function. So t to the 1/2, we bring down the 1/2. And then we have t to the 1/2, so 1/2 minus 1, which same thing as saying 2 over 2. So 1/2 minus 2 over 2 gives us t to the negative 1/2. Plus, now for our second term, we leave f alone, so this is going to be t to the 1/2. And then we're going to multiply this by this g, derivative of g. So a is a constant, so the derivative of a is going to be 0 plus derivative of bt. Well, you can think of t as t to the 1. You bring the 1 down, it becomes t to the 0. T to the 0 is equal to 1, so this just means it's going to be times b. Now, just to eliminate some confusion, so I don't confuse this as a 6, I'm going to write this as a capital B from now on, just so that I don't accidentally end up multiplying by 6, because I've done this in the past. Okay, so now I'm going to simplify this sum. So the first thing I'm going to do is I'm going to rewrite this as a plus bt, and then I have 1 over 2, so this is going to be over 2, and then t to the negative 1/2. T to the negative 1/2, remember the negative power makes it go to the denominator, so this would be over t to the 1/2. And then I'm just going to put it back in terms of square roots just to get it back into its original form. So this is going to be square root of t in the bottom, because it's 1/2 means it's a square root. And then this is going to be plus b square root of t over 1. Now, in order to simplify this, first thing I need to do is I need to get both of these fractions in terms of the same denominator. So I'm going to take this one and I'm going to multiply by 2 square root of t over 2 square root of t, which I can do because this is 2 square root of t over 2 square root of t, same thing as 1, which means I'm not really changing this. So if I were to then solve for this, this is going to end up being a plus bt plus, and then we have 2b square root of t times square root of t gives us t. And then this is all divided by, because we got 2 square root of t over 2 square root of t. So this is going to be 2 square root of t. And then finally, what I'm going to do is I'm going to combine these two terms, right? I've got bt plus 2bt. So this is the same thing as saying a plus 3bt divided by 2 square root of t. What about if we have a problem like we've had before, where we have what the outcomes are, but we don't know what the actual functions are? So in this case, we have that h of x is equal to x times g of x. We have that g of 3 is equal to 5. We have g prime of 3 is equal to 2. And we want to figure out what is h prime of 3. So the fact that h of x is equal to x times g of x, right? X in this case is our f. G of x is our g. So whenever we're solving for this, we know that we want to take g f prime. So in this case, we're going to take g of x, which in this case is for 3, times the derivative of x, which is going to be d dx x plus. Now we're going to leave f alone, so this is going to be x times the derivative d dx of g of x, which in this case is g of 3. The derivative of d dx of x is just going to be, if you can think of this as x to the 1, this is going to be the same thing as multiplying by 1. So g of 3 is going to be equal to 5 times 1 plus, now for x, because we're not changing it, we're just plugging in this 3, right? Because this is h prime of x. X is equal to 3, so this is going to be 3 times the derivative of g at 3, which is going to be equal to 2. So we're going to have 5 times 3 times 2, which is 6, is going to give us 11. Okay, so we've done some examples with the product rule. Now let's do one with the quotient rule. So we have y is equal to x squared plus x minus 2 divided by x cubed plus 6. And we want to figure out what is the derivative. So we want to figure out what y prime is. So in this case, this top term is my f, this bottom term is my g. So we're going to be using the quotient rule, g f prime minus f g prime divided by g squared. So then plugging that in, our first thing, g, we're going to leave this alone. So this is going to be x cubed plus 6 times. Now we want to take the derivative of our f term, which is going to be x squared plus x minus 2. So we'll take the derivative of that, of course, x squared, right? Because if I take the derivative of x squared plus x minus 2, it's the same thing as taking the derivative of x squared plus the derivative of x minus the derivative of 2. So the derivative of x squared, we're going to use power rule. This is going to be 2x. We take the derivative of x. This is going to be equal to 1. And then, of course, we take the derivative of a constant. Derivative of a constant is always equal to 0. So now we're going to subtract f. So we're going to leave our f alone this time. So this is going to be x squared plus x minus 2 times the derivative of g of x. So we're going to take the derivative now of this. Same thing, I can take the derivative of x cubed plus the derivative of 6. Derivative of x cubed is going to be 3x squared plus the derivative of a constant. Derivative of a constant is equal to 0. So we're just going to be left with 3x squared. And then all of this is divided by g squared, which means that we're going to take this bottom term, x cubed plus 6, and we're going to square the entire thing. So now let's see what we can do to simplify this. So the first thing I'm going to do is I'm going to FOIL out these first two terms. So I have 2x times x cubed. This is going to be 2x to the 4th power. Plus, now we're going to do our outer terms. X cubed times 1 is going to be x cubed. Now we're going to do our inner terms. 6 times 2x is going to give me 12x. And then I'm going to do my last terms. 6 times 1 is going to be plus 1. And then I'm also going to distribute this 3x squared into each of these, remembering that I'm subtracting this. So whatever I get, I'm going to flip the sign. So I have 3x squared times x squared is going to be minus 3x to the 4th power, right? Because it's 3x to the 4th power. It's positive, but then the minus makes it negative. And the next one is going to be minus 3x cubed. And then the last one is going to be 3x squared times negative 2 gives me negative 6x squared, but then the negative is going to make it positive 6x squared. So plus 6x squared. And this whole thing is still divided by x cubed plus 6 squared. Okay, so let's see if there's any cancellation. So the first thing is that I've got 2x to the 4th and I've got minus 3x to the 4th. So this is going to give me minus x to the fourth power. So I've used this one, and I've used this one. Now let's look at our cube terms. We have x cubed, we have minus 3x cubed. This is going to give us minus 2x cubed. And again, we've used this one and this one. Now let's look at our square terms. Well, it looks like the only square term we have is going to be the 6x. So plus 6x squared. Next, we look at our x's. We have plus 12x. And then finally, we have, for our constants, plus 1. And then don't forget our denominator, which is going to be x cubed plus 6 squared. And this is about as simple as we're probably going to be able to make this one. So in this case, this would be our final answer. For my next problem, I want to take the function y is equal to e to the x divided by 1 plus x squared. And I want to find the equation for the tangent line at the point 1/1/2 e. So to find the tangent line, first thing we need to do is we need to figure out what is the derivative. That's going to give us our slope. So to find our derivative, y prime, we're going to use the fact that because this is e to the x divided by 1 plus x squared, we know this is going to be the quotient rule, where e to the x is f, 1 plus x squared is our g. So we're going to have g, we're going to leave g alone, so this is going to be 1 plus x squared times. Now we're going to take the derivative of e to the x. Well, derivative of e to the x is just e to the x minus. Now we're going to leave f alone, so this is again going to be e to the x. And we're going to multiply this by the derivative of our g term. So derivative of 1, derivative of constant, is equal to 0, plus derivative of x squared is going to be 2x. So this is going to be e to the x times 2x. And then this entire thing is going to be divided by gx squared. So we're going to take 1 plus x squared squared. Now there's two ways you can solve this. Since we want to find it at the point 1/1/2 e, you could plug in your x now, which then would give you y prime of 1 is going to be equal to 1 plus 1 squared is equal to 1 e to the x minus, actually plug in 1 for that too, e to the 1, e to the x, plug in 1 for x, times 2 to the x. So this is going to end up being two e minus 2e over 1 plus, I forgot to put the 1 in here, so this should have been 1 plus 1, or 2 squared, which is equal to 4. So we get 0 over 4. The other way you could do it, going back to this, is whenever we found this, we actually could pull an e out, right? This has an e to the x, this has an e to the x. So we would have that y prime of x is equal to e to the x, 1 plus x squared minus 2x over 1 plus x squared squared. Now, if I were to then plug my x equals 1 in now, this is going to become 1 plus 1 minus 2. So this would be e to the x, 1 plus 1, which is equal to 2, minus 2 over, again, plug this in, this will give us 4. So 2 minus 2, this term is going to go to 0. We end up with the same thing, 0 over 4. So if you had simplified it first, you would still get the same answer. So now we have what our slope is at x equals 1. Our slope, m, is equal to 0. So now what we need to do is we need to figure out what is the formula for our tangent line. So we're going to plug in x as 1 and y as 1/2 e, and we're going to plug this into our point slope formula, y minus y1 equals m x minus x1. So this would be y minus 1/2 e equals 0 times x minus 1. So of course I'm going to distribute the 0. 0 times x is 0. 0 times negative 1 is 0. So we're going to have y minus 1/2 e equals 0, which is going to give us y equals 1/2 e. So this is the function, or this is the formula equation of our tangent line at x equals 1, y equals 1/2 e. It is just y equals 1/2 e. For our next example, we want to solve the function. We have the function f of x equals 3x squared plus 2 square root of x divided by x. And we want to figure out what is the derivative of this without using our quotient rule. So in order to do this, what I'm actually going to do is I'm going to take my f of x, and I'm actually going to change it around a little bit so that, first of all, this is this x square root of x is going to be x to the 1/2. So we're going to have 3x squared plus 2x to the 1/2 divided by x. And then what I'm actually going to do is I'm going to split this into two separate fractions. So this is going to be 3x squared divided by x plus 2x to the 1/2 divided by x. So then this x is going to cancel with one of these x's, leaving me 3x plus. Now, when I have this x here, this is the same thing as, I'm going to rewrite this. So we have 2x to the 1/2 times x to the -1, right? Because remember, just a -1 just brings it to the denominator. So if I have something in the denominator, in this case x, if I give it a negative power, it's going to take it into the numerator. So if I have two x's with different powers multiplied by each other, you just add them together. So x to the 1/2 times x to the -1 is the same thing as x to the 1/2 plus -1, so -1. I can change this 1 into 2 over 2, so I have x to the 1/2 minus 2/2 leaves me with x to the -1/2. So this means that my function is now 3x times, plus 2 times x to the -1/2. And now I can actually solve this just using my power rule. So I have 3x, you can think of this as x to the 1. So when I take the derivative of this, using my power rule, 3x just becomes 3 plus, and then if I do my power rule on this, it's going to be, I'm going to bring down a -1/2, so I'm going to get minus, so I got the 2 over here, so 2 over 2, and then I'm going to subtract 1 from my power, so this is going to be minus 3/2. And then 2 over 2 just gives me 1, so I'm left with 3 minus x to the -3/2, which if you remember, the negative is going to put this in the denominator. So I'm going to have 1 over x to the 3/2. And then rewriting this, I will get that this is equal to 3 minus 1 over x to the 3/2. The 3 means that it's x cubed, and the 1/2 power means that it is the square root. So this means that my final derivative is 3 minus 1 over the square root of x cubed. Now, the reason I actually wanted to show you this example is to show you that sometimes there are a lot of different ways that you could solve this. For example, when we got it into this original form, I could have instead used the quotient rule, right? Saying that this is f, this is g, and I could solve this and I would get the same exact thing. In fact, you know what? Let's try that. So if I take my derivative, f prime of x, this is going to be equal to g, so we're going to leave g alone, that's x, times the derivative of 3x squared, which is going to be 6x, and then plus the derivative of 2x to the 1/2, so bring down the 1/2, this is going to be plus 2 over 2, which would just be 1, and then 1/2 minus 1 is going to give me to the -1/2. Minus. Now for my f term, I'm going to leave this alone, so this is going to be 3x squared plus 2x to the 1/2 times, now I'm going to take the derivative of my g term. Derivative of x is just equal to 1. And then I will take my g value, so in this case x, and I will square that. So now, solving for this, what do we do? Well, first things first, I'm going to distribute this x. So this is going to become 6x squared plus x to the -1/2 times x. So -1/2 plus 1 gives me x to the 1/2. So to the positive 1/2. And then this one, I'm just going to distribute the negative. So minus 3x squared plus 2x to the 1/2 divided by x. Now, of course, I can now divide everything out by this x. So in this case, actually, first thing I'm going to do is I'm going to take this x to the 1/2 and I'm going to bring it over here with this 2x to the 1/2, which should have been negative because I distributed a negative. So we have x to the 1/2 minus 2x to the 1/2 gives me, so this would be 6x squared minus 3x squared. I should actually need to combine those terms too. X to the 1/2 minus 2x to the 1/2 gives me minus x to the 1/2. Still divided by x squared. 6x squared minus 3x squared. So this is going to be 3x squared minus x to the 1/2 divided by x squared. Now, if I were to split this like I did before, this is going to be 3x squared divided by x squared minus x to the 1/2 divided by x squared. So for this one, 3x squared divided by x squared, this is just going to be equal to 3. And then we have x to the 1/2 divided by x squared. So again, I'm going to treat this as x to the -2 power. That would be the same thing as saying -4 over 2. So 1 over 2 minus 4 over 2 gives me x to the -3 over 2, which then of course brings us right back to where we were, 3 minus 1 over the square root of x cubed. So just like we got before, using the quotient rule, or in fact rearranging our original function so that we could just use the power rule. For our last example, I have the function f of x, which is equal to secant of x divided by 1 plus tangent of x. So we're still going to be using our quotient rule, where this is going to be our f term, this is going to be our g term, but now we're using some of our trig identities that we looked at earlier. So first things first, leave g alone. So the derivative of this, I'm going to leave my g term alone. This is going to be 1 plus tangent of x times, now I'm going to take my derivative of my f term. This is going to be, so actually let me write this down first. This is going to be d dx secant x. Let me do that so that nobody gets lost. So the next one, I'm going to leave f alone. So this is going to be secant x. And then times the derivative d dx of 1 plus tangent x. And this whole thing is going to be divided by 1 plus tangent of x squared. Okay, so now, actually solving for this, we're going to have 1 plus tangent of x. And now what I need to do is I need to take my derivative of secant of x. This is just going to be equal to secant of x tangent of x. And then minus secant of x times the derivative of 1 plus tangent x. So the derivative of 1, which is a constant, is going to be equal to 0. So we're just taking the derivative of tangent x, which is going to be equal to secant square of x. And then this whole thing is still divided by 1 plus tangent x squared. Okay, so now that I've taken the derivative, let's simplify some. So as always, first thing I'm going to do is I'm going to distribute this to this term here. So we're going to get 1 times secant x tangent x. So we have secant x tangent x plus. Now I'm going to multiply tangent x by secant x tangent x. So this is going to be secant x tangent square of x minus secant x times secant squared of x, which is going to be secant cubed x divided by 1 plus tangent of x squared. So here what we're going to do is we're going to use a trig identity, which is 1 plus tangent square of x is equal to secant square of x. Now, you might think that I'm actually using this to get rid of our denominator, but I'm actually not, because if I were to distribute this, I would have to FOIL it out. It doesn't end up being what we're looking for. So what I'm actually going to do is I'm going to replace this, one of these, the secant squared here, this is secant cubed, by the way, so just be careful, with 1 plus tangent square x. So this is going to give me secant of x tangent of x plus secant of x tangent square of x minus secant of x times 1 plus tangent square of x. And again, all of this is still divided by 1 plus tangent of x squared. Now you might have wondered why I did this. Well, it's because now, if you look at this, I have secant here, I have secant here, I have secant here. So if I were to pull secant out, so I have secant x, this is going to be tangent x plus tangent square x minus 1 minus tangent square of x, all divided by 1 plus tangent of x squared. I have tangent square of x minus tangent square of x. So these two are going to cancel with each other. And this is going to leave me then with secant of x times tangent of x minus 1 divided by 1 plus tangent of x squared. And this is about as simple as I can think to make it. There might be other identities you could use. For example, you could try changing secant and tangent into sines and cosines. There might be more cancellation you can do, but honestly, I feel pretty good about this being our final answer. So not only did we take the derivative using the quotient rule, we were able to distribute all the terms, and then using this identity here for secant square x equal to 1 plus tangent square x, we were able to actually cancel some of our terms, giving us a slightly easier trig function at the end to work with. So that is it for our product and quotient rule lesson. I am actually going to do a supplementary lesson where I'm going to prove the product and the quotient rule that they're true using our basic definition of a derivative. So that way you don't have to use the definition of a derivative using your difference quotient every single time. These rules will always be true. So I'm just going to show you these as an example of how this works. So you should be able to find that video. I'll put a link to it in the description below. Other than that, that's it for this lesson. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.